Lesson 832, Classifying Angles. Daily learning target. By the end of the period, the students will classify angles and angle pairs. They will use angle pair properties to solve equations. The end class is 8-66 to 8-71. The homework is 8-74 to 8-79. Okay, here we go. 8-66 to 8-71, lesson 832, classifying angles. You will need a protractor like this for this lesson. Alright. Question 66. In geometry, an angle is formed by two rays with a common endpoint. A ray is a line that has an endpoint that extends indefinitely in a particular direction. The point where the two rays intersect is called the vertex. So this is the vertex. Right here. I like to call it like the corner of the angle. Okay. One of the most common angles is a right angle. A right angle measures 90 degrees. Right angle, 90 degrees. If an angle measures less than 90 degrees, it's called acute. Okay. If an angle measures more than 90 degrees, it's called obtuse. Got a little vocabulary in there already. Use a protractor to find the measure of each angle and then classify it according to its measure. Okay, so when you're using a protractor to measure an angle, this little plus right here on here has to fit right on the vertex, and then one of the rays has to lay right on this line. So if I put this like this, line it up, you can tell that this is pointing at looks like 35 degrees. Let me get the measurements down, then we'll go back and classify it. Okay, this one, line that up, it's opening this way, is at 120 degrees. And this one, oh, it's upside down. This one, look at that, it's exactly 90. Okay, so if it's 35 degrees, it's less than 90. And what did we call that up here? We called it acute. 120 is greater than 90, so this one is obtuse. And exactly 90 is right. It's a right angle. Okay. A straight angle is also called a straight line. Draw a straight angle on your paper. Okay, well, I'll just use this. Lovely. And I'll say there's my vertex. And so going from here to here this way is 180 degrees. Hold on a second. My protractor keeps wanting to run away. Okay. Next page. Says the diagram 867. The diagrams below show some students' use of protractors. Explain what each student needs to do to find the correct angle measurement. Okay, so if this is the vertex right here, it's supposed to be like right here. So vertex needs to be on center of protractor. This one, one side of angle needs to be at 0 degrees, or find difference between the two sides, or what they were calling the rays. Okay, this one I'll have here. Oh, see this? Here's the vertex. The center's down here. Okay. Or the zero's right here. Okay, so one side of angle needs to be at 0 degrees. Okay? And if this is your angle right here, this big one, look, that's supposed to be greater than 90, and they're saying it's 60. So read the protractor scale starting at 0 degrees. Because 0 degrees is here, and it opened this way. So, complementary angles are two angles that add up to 90. Supplementary angles are two angles who add up to 180. Okay. Just use your protractor to measure each of the angles below and determine which angles are complementary and which angles are supplementary. Ew. Alrighty. Let's measure them then first. Okay. Get that right on that vertex. Line that up. This one is 127 degrees. This one is 53. And this one, oh, this upside down one, is 37. So let's see. If I add up A and B, that would be 180. Okay, so here, let's do this. B and C are complementary. Is this on screen? Come on, let me get straight now. Because 53 plus 37 equals 90. Okay. A and B are supplementary. Because 127 plus 53 equals 180. Says, with your team, come up with a strategy for remembering the definitions of complementary and supplementary. Okay. C comes before S. And 90 comes before 180 on a number line. So C goes with the smaller number, S goes with the larger number. Focus. Oh my Lord, was I a focus on one? Keep going. There's a lot of vocabulary in this lesson. Question 69. Okay. Adjacent angles. Angles that share the same vertex, so the same corner, and one side are referred to as adjacent. Adjacent means next to. Next to. Adjacent. Adjacent. For two angles to be adjacent, they must satisfy the following three conditions. Condition number 1. The two angles must have a common or shared side. 2, they must have a common vertex. Okay? 3. They can have no interior points in common. No overlapping is permitted. The common side must be between the two angles. Okay, so each of the figures below, determine which pair of angles are adjacent and which are not by checking to see if each pair satisfies all 3 conditions. Write yes or no next to each figure. If you write no, give a short explanation. So, look. Common vertex, shared side. This is yes. They are adjacent. Okay, oops. 2 different vertices. No. No. No common vertex. Like it, letter C. This is no. Has common interior points. And the side that they share here is supposed to be between the 2 of them, and it's at the end. Okay. Look what's going on with D. This is a big fat no. No. No common vertex or side. No. Common vertex, side in the middle. Okay, so this is yes. They are adjacent. Okay, 1 and 2. Well, they don't have a side that's the same because there's this thing in the middle. Let's look at this thing separates them. So no. No common side. Okay, they have the same vertex, but they don't have a common side. No. No common, please be on camera, side. Okay, look at this one, this angle here, and this angle here. What? No. No common vertex. And then this one, same vertex, common side. Yes. They are adjacent. Well, that was kind of fun. All right. Let's go to the next page. Oh, this is a long one, huh? Vertical angles. Oh, it's like the lesson of everything you want to know about angles. Okay, vertical angles. Angles formed by 2 intersecting lines that are not adjacent are called vertical. In the diagram at the right, 1 and 2, see how they're across from each other? Are vertical angles. What can you say about 3 and 4? Well, they're across from each other, so they are also vertical. 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 I spelled vertical wrong, didn't I? I sure did. Mrs. Caldwell. Use your protractor to measure each of the 4 angles. Oh, Mr. Protractor, Mr. Protractor. So let's measure 1. I have to scoot this down. Can you still see? Yeah. So this one looks like it is 33 degrees. Oh, see this little thing right here? This means angle. Angle 2. Oh, 33 degrees. Angle 3. That's a big one. Don't move it out of screen. I can't see. What is that? 147. Let's get out. 147 degrees. And angle 4, Mr. Upside Down. What did you notice? What did we notice? Vertical angles have the same measure. They're equal. So draw a pair of vertical angles on your paper. Okay, vertical angles. I'm going to say A and B. A and B are vertical. What do you think is true about the measure of the vertical angles? Vertical angles, that's an S, have equal measures. Okay, last part. 71. Find the measure of each of the missing angles. Okay, so this is a straight angle, and that's supposed to be 180 degrees. So if this one's 75, do 180 minus 75. Borrow. So this one's 105. That's a degree. Okay, these are vertical angles, and we say they have the same measure, so if one is 55, the one across from it, the vertical one, is also 55. Okay, so it says 1 and 2 are complementary. Complementary means they equal 90. So if this one's 27, what's 90 minus 27? Borrow 63. Okay, ooh, look at this one. These are supplementary, so these have to equal 180. So if this one's 30, I'm going to show my work. What's 180 minus 30? 150. Fun! I like those. Let's put some of those in our quiz. All right. Your homework is to do 8-74 to 8-79. Bye-bye.